We have this lovely definition. M is supposed to stand for the number of complete cycles. P is the period. And every time you do a complete cycle, it's like you come back to the beginning of the graph again, back at f of 0. So before we get to the official example, let's do something more down to earth. If it is now 1 p.m., 1300 hours in military time, what time will it be 100 hours from now? Let's make it 99. Well, 99 hours, that's more than a day. That's more than 2 days. In fact, it's more than 3 days. So we're going to have to find out, split these hours up into days. Now, each day is like a period. It's a cycle of hours, one complete cycle. So we're going to take 24 into the 99, split it up into hours. 2 divides into 9 twice. 4 times. So I'm hoping that 4 times 24 will work. If it doesn't, we'll try something else. But it does. In fact, we have 3 left over. So this means this 99 hours is 4 full days. 4 full 24-hour days. "24 hours is our period. We have 4 of these periods. That's like being back at f of 0 again. Plus, we have 3 extra hours beyond that. So this would take us 4 days from now at 1 p.m., 1300 hours, and we've got another 3 extra hours past that. So 100 hours from now, we would be at 1600 hours, or in civilian time, we would be at 4 p.m. "99 hours from now. It would be 4 days. 4 days would take us to 1 p.m. 4 days from now, plus 3 extra hours, it's 4 p.m. How can this relate to a periodic function? Well, if f of t is the time of day t hours from now, then f of 99 is going to be exactly the same as f of 3. The time of day 99 hours from now equals the time of day 3 hours from now. It'll be 4 days later, but the clock time will be the same. And that's the kind of logic we're going to use to solve these periodic function problems. So the official example here is going to be very similar, except that it's not 99 hours from now. So we're not going to split it up into 24-hour days. We will be using this equation, but we're going to just do the work to fill in the blanks. We can't do it at all unless we know how far along the period is. Every how many spaces, when do we start over? So that's why they ask us what's the fundamental period. Well, we can count from peak to peak, bottom to bottom, count from 0 till it starts to repeat. We could count from this peak to that peak. So this peak is -3. The next peak up is at +1. From -3 to +1, that's 4 spaces. If you don't like that, you could start here at 0. Goes up, it goes down, comes back up, and it's ready to start again at x = 4, from 0 to 4. So the period is 4. And they want to know, if we keep repeating every 4 spaces, where will we be when x is 99? And you could draw it. We don't need to. One complete cycle is going to take us out 4 spaces. Next complete cycle is going to take us out another 4 spaces to 8. Third complete cycle is going to take us out another 4 spaces to 12. We can just divide this 99 up by 4. So we divide 4 into 99. It's like that goes twice. I'm doing it the old-fashioned way here. And we have 3 left over. So this is 24 full cycles of 4. This is like being back at the beginning. But we have 3 extra spaces to the right of that. So that would be like f of 3, which means the y value at x = 99 is exactly the same as the y value at x = 3. So f of 99 is going to be exactly the same as f of 3. We got to go to the graph. What is the function value when x = 3? Well, it's looking like it's 2 below. So to answer the question they posed, the function value at 99 is the same as the function value at 3, and according to the graph, that equals -2. Let's try a couple more. I'm just going to call this one part C. Find the function value when x equals 49. Going to go 49 spaces out. It comes back to the beginning every 4 spaces. So we could find out how many full cycles do we have. I know a lot of you can do this immediately in your head, that would have to be 12 times with 1 left over. So we have 12 full cycles, which takes us back to f of 0, and 1 space extra to the right. And it's to the right because the remainder is positive 1. So, y value at x equals 49 is the same as the y value at x equals 1. Function value for 49 is the same as the function value for 1. According to the graph, when x equals 1, the y value is 2. So f of 49 is the same as the y value at 1, and that was 1. I'm sorry, that was 2. At x equals 1, the y value is 2 spaces up. One more. Suppose it's f of negative 34. So it's headed in this direction. It's still repeating every 4 spaces, though. So we can take 4 into negative 34. That goes negative 8 times. And when we subtract negative 32, that's like negative 34 plus 32. So we have a remainder of negative 2. So we have 8 full cycles to the left. Which we could draw 8 full cycles out here to the left. Don't want to. That puts us same value as f of 0. And we have 2 extra spaces to the left of that. So, the y value at x equals negative 34, same as y value at x equals negative 2. Just look at the graph. According to the graph, when x equals negative 2, y is 0. I've got 0 as y. So f of negative 34 was the same as the function value at negative 2. And the function value at negative 2, according to the graph, was 0. So would you please try some on your own on the You Try class exercises? And then come back to check your answers.